So, good afternoon. It's my great honor and delight to be introducing Dr. David DeLiema. David got his BA from UCLA in Communication Studies with a minor in Spanish. I guess he really liked UCLA, or at least the surfing down there in San Monica, because he stayed on there at the Grad School of Education Information Studies and under the advisorship of Berkeley's own Noel Enyedi to receive just last year's PhD in Human Development and Psychology. I think of David as a classical learning sciences person with 1 foot in cognition, 1 foot in socio-cultural theory, and 1 foot, that kind of went wrong, in educational technology. And he'll be telling you about his research today, but I'll add just that he's already published with co-authored papers in the International Journal of Computer-Supported Collaborative Learning, a couple of chapters, and a handful of first-authored conference proceedings. David joined here, the GSC, this fall as a postdoctoral fellow on a 3-year grant that our lab just received from NSF in collaboration with UCLA and 9 Dots, which is an after-school urban youth club where we're studying academic resilience in computer science courses. David literally wrote the whole grant with us standing back in awe and occasionally just whispering some mediocre advice that he graciously incorporated. I'll just say that David is a real treasure to have around, and I encourage all of you to take advantage of him while he's here. And we greatly look forward to working with him on the project during this fellowship. And I'll end off with this. He's already gained heartfelt esteem here as a STEM EdTech equity dreamer, though from UCLA, he's good stuff anyway. Please welcome Dr. David DeLiema.
I'm not sure I can follow that. I'm really excited to be joining you all. Dora and I have been collaborating ever so slightly over the years, and to get to join you all is very exciting. I'm going to start off by reading a story to you. Has anyone read anything from the collected stories of Lydia Davis? 1 thumbs up. Very cool stuff. So this will go very, she writes very densely, so it's like sort of like playing with words a bit, but I think the message is really interesting. So I didn't know if I should show you the text and read it also, but I'm gonna read it and I'll try to read it slowly. If only I had a chance to learn from my mistakes, I would, but there are too many things you don't do twice. In fact, the most important things are things you don't do twice, so you can't do them better the second time. You do something wrong and see what the right thing would have been and are ready to do it should you have the chance again, but the next experience is quite different and your judgment is wrong again. And though you are now prepared for this experience should it repeat itself, you are not prepared for the next experience. If only, for instance, you could get married at 18 twice. Then the second time, you could make sure you are not too young to do this, because you would have the perspective of being older and would know that the person advising you to marry this man was giving you the wrong advice because his reasons were the same one he gave you the last time he advised you to get married at 18. If you could bring a child from a first marriage into a second marriage a second time, you would know that generosity could turn to resentment if you did not do the right things, and resentment back to kindness if you did, unless the man you married when you married a second time for the second time was quite different in temperament from the man you married when you married a second time for the first time, in which case you would have to marry that one twice also in order to learn just what the wisest course would be to take with a man of his temperament. And then it goes a little bit further, but we'll stop there. So this is a somewhat cynical view of mistakes. She's sort of cheekily pointing out that context changes too much from one setting to another setting. The person is different, you're older, something has changed that prevents you from applying the thing you learned in the first context to the second context. So you could say, you could look at the situated cognition literature, the extended cognition literature, dynamical systems, and you could try to pull an argument out of that, say context change is too much. There's also infinite causes of failure. This is a sort of, I suppose there's alternative views about these causal theories, but one view is that any given event is a result of a cascade of infinite events that came before it. And well, what do you do? How are you going to learn from an infinite amount of events that have caused an outcome? And I think Lydia Davis is right that we only get one chance with big events. But there's another way to think about this, that there's actually a lot to be learned. Context is stable enough. The tools might be the same, the people might be the same. It's not like we're radically different people from one moment to the next. So you could try a different argument, say, wait a minute, no, context is the same. Interestingly, humans are really interested in reflecting on failure. If you read narrative theory, storytelling is storytelling about breaches in sort of normal behavior. They're stories about failure. If you just look at the news is about failure. We digest the stuff constantly, so we're really interested in it. And failures happen repeatedly. Whether you like it or not, they just do. And you can say, all right, so that actually sets decent conditions for learning. A community that does this really well, I think all professional practice communities have to do this one way or another. But computer scientists really have this down pat. So debugging is what they call it. It's at the heart of their programming practice. So a colloquial definition of debugging, how to find out what's wrong with stuff quick, finding a fix. A more technical definition, initially the program state is sane, eventually it is infected. The aim of debugging is to find out where this infection originated. They use this in sane state, infected state, because it's literally crystal clear in a program when it has been infected, when it's switching from the correct behavior to the wrong behavior. Computer scientists are unusually reflective about debugging. These are 3 books that I've bought and read recently. They're massive tomes about how to debug. I mean, what other professional practice has tomes dedicated to what to do when you fail in that practice? It's like somewhat odd that there isn't a debugging equivalent in every other community of practice. And then for education, it's quite an interesting moment, debugging, because it's very often collaborative. You're incredibly proactive in that moment. It requires creativity. It's not just grit. You don't just push and overcome your bug. You have to think very reflectively about it. And it's frustrating, of course, and yet it's completely routine. It's normalized in computer science. So Dora alluded to this, that with UCLA, with Noel Entity and Francis Steen, and with 9 Dots, we're just at the cusp of a project where we're going to try to foster a strong debugging culture with underserved students who are learning how to code for the first time or for the second time. They sort of move through a few workshops at this learning center. So this is our big goal. And it's a little bit hard. I struggled with what I should share with you all today because we haven't done the project. We got the funding 2 weeks ago, so I don't have results for you, and I thought I could ignore it and just share my old work with you. But I'm trying to find a way to do both at the same time because I'd love for you all to know about this project in case you're interested in it. As Thor said, we would just love to have more people involved and for me to learn from all of your expertise since I'm brand new here. So I thought I would tell you about the interventions that we are planning. And so what are we actually going to do with the students? And to tell you how we're thinking about designing these interventions, I'm going to give you just a window into our thinking. And a lot of our thinking comes from my prior research, so it gives me an excuse to share my research with you. So the 3 interventions that we're thinking of are setting new norms in the community, building a curriculum and software, and doing professional development with the undergraduate students who come in and tutor the students in computer science. So if you fit these interventions onto I'm actually glad the text is blurry because I didn't want you to read it anyway. If you fit this onto a conjecture map, which is often a way that folks organize design-based research projects, these are our interventions that we're embodying. These are the mediating outcomes that we expect, like the short-term things we want to see in the community. And these are the outcomes, the big outcomes of our study, and we're driving towards this big goal of building a strong debugging culture. So for today, I'm just going to basically tell the story of our conjectures, what conjectures we're using to design our norms, our curriculum, and our software. So these are the three conjectures that we're gonna walk through. And what's gonna happen in the talk is I'm gonna dive into the details of this, and we're gonna basically leave computer science fully behind as I share that project and the results from it. And then at the end, I'll map it over to computer science. So if you feel like we're getting lost in the weeds, it's because we are. We're looking at just these specific conjectures, then I'll come back and map it onto our interventions. So in short, these conjectures focus on storytelling in a failure moment. And these failure stories have a temporal structure, division of labor, and a content that we can take advantage of in our design. The second part is looking at a whole bunch of situated epistemic resources that come together to create knowledge and how we can use that to inform our design. And the last piece is metacognition, having the students and the tutors at the center reflect on both of these processes. Reflect on how they're telling stories about failure, reflect on what resources they're using to build knowledge, and in that way give them the agency to design their own debugging practices. So the one that we'll start out with first is failure stories, that they have a temporal structure, division of labor, and content. I'm going to use Vygotsky's zone of proximal development just for a little bit as an organizational device. Students' existing skills here, their zone of proximal development, the skills they're about to develop into, and then what we could say like the zone of distal development, very far away from their immediate skill set. And what's interesting is that the edge of your existing skills in the ZPD, you just are going to run into points of failure all the time. So there's a few ways that folks have tried to deal with failure. A common one right now is grit. And grit is persistence towards very long-term goals, hitting a whole bunch of failures en route to your goal and persisting. Growth mindset is having the idea that you can become smarter over time, that you can develop your skills over time, and it's hitting that failure and saying, look, I'm going to be able to do it. I believe I can grow my skill set over time. Mental contrasting looks at a person could think, wow, I'm here and I don't have any skills, but I want to be there with lots of skills. And that contrast that you sort of run in your own imagination is motivating. There's also a design approach to this called productive failure, where instead of just waiting for that failure moment to happen, we design for it intentionally. You get the student to fail. Your curriculum is supposed to do it. Student fails early, they reflect on their strategy, they generate questions, and only then do they receive scaffolding from the instructor. So we're keeping these in mind as we work on this project, but the one that we really want to focus on is zooming in really precisely at this failure moment. And we want to look at the stories that the students and the tutors are co-constructing at the moment that obstacle presents itself. They're not the kinds of stories that you would want to go see in the movie theater. They're quite mundane stories, but they say a lot of really profound things about how students are thinking about themselves and how the teacher's thinking about the student and whatnot. And these stories have a temporal structure. They focus on the past and they plan for the future. In Bruner's terms, narrative theorist, one of the principal ways in which we work mentally in common, I want to argue, is by the process of joint narrative construal. So this narrative device is quite powerful, and it's something that we use together to think in interaction. And this is a fancy way of saying that we use it when there are breaches. It's essentially the definition of a narrative. A narrative is a sequence in time where you're trying to capture the experience of the people inside of it, and you do it when there's a breach. It's interesting to us when there's a breach, otherwise it's not a motivating story. Maybe the most recognized theory to treat this, though it's not focused on narrative, is attribution theory. Attribution theory focuses on the things to which we attribute our failures. And when you attribute your failure to something such as ability or instructor bias or luck, teacher assistance, you can try to fit it to this table here. where the factor that you blamed is inside of you or it's outside of you. It's something you can control or something you can't control, and it's something that's stable or unstable. And what this does is it predicts whether you will be motivated. So they argue that people conceive of ability as something that's internal, something that's uncontrollable, and something that's stable. So if you blame your failure on ability, there's not much you can do about it, and your motivation is expected to drop. However, if you blame immediate effort, it's something that's controllable and it's unstable. The amount of effort that you apply at any point is variable, and you can notch it up. So motivation would be expected to rise. This is just the attribution framework theory. So we can look at a few stories. I just pulled a few from the news. This is Steve Coburn after California Chrome. His horse lost in the Triple Crown just by a hair, not by much. And he gets interviewed right after, and he says, "I will never see another Triple Crown winner because of the way they let other horses rest before races." Basically, Chrome's competitors didn't have to race in as many races as Chrome did, so they're on more rest. So this is external. It's stable. It hasn't changed in years, that rule, and not much Coburn can do about it. He just owns a horse, but he doesn't set the rules. But a moment later, he adds, "Horse simply didn't have it in him," right? Which is internal, in him. He didn't have it in him. It's unstable, right? Like today, he just didn't have it in him. And then I'll leave it to horse whisperers to tell me if it's controllable or uncontrollable. I don't know if you can get a horse to be a little more motivated before a race. To show you another example, this is Kevin Jorgensen, who climbed the Dawn Wall in Yosemite, which was apparently the toughest ever rock climb, with a partner. His partner had passed this tough section. He fell on it 10 times over the course of a week, and he couldn't pass it. He's sitting dangling on the side of the mountain, trying to figure out what to do. He ends up watching a video of himself, and here's what he finds. Each fall had to do with a single foot placement, a millimeter change in the angle of my right front foot on the exact same piece of rock. Before, it didn't match the contours of this tiny little pebble that I was trying to step on. So in this case, it's internal. It was stable. He made the mistake 10 times in a row. It wasn't going to change. But interesting, it's controllable. He just needs to change the angle of his foot a little bit. So you can sort of take attribution theory and see the structure of people's stories and how they overcome.
Did he overcome?
Yeah, he overcame it. Yes. Yeah, this was the story he told at the end. Yeah, and it was historic. Yeah, he was about to give up. So if you look at the research on failure, what we know a lot about is how students respond to surveys, forced choice questionnaires, or what you could say an interview. So here's me interviewing a student. What we know less about, and if you think about the structure of both Jorgensen's story and Coburn's story, they're all post hoc. They're after the failure has happened. What happens in the moment that you're working on a math problem and the obstacle hits? In that moment, what's the story that you tell? So this is the research question that I was going for in this study. How do tutors and students jointly construct, co-narrate stories about moments of failure during math tutoring sessions? This took place at a nonprofit after-school learning center with 4th and 5th grade students from non-dominant communities, mostly native Spanish speakers. And there were 2 epistemic ends of the program. When I say knowledge and understanding, the learning center wanted the students to get the right answers. They wanted to know the answers, but they also wanted the students to understand what they were doing. So I focused very closely on 7 dyads and looked at 21 failure conversations and narrowed it down to 7 for the purpose of showing diversity of these failure moments, not for it to be generalizable in any way. This uses the method of interaction analysis, and I reflected on theory, and would go back to the data, back to the theory, back to the data. Okay, so first finding. These stories begin with someone pointing out an obstacle, pointing out that something has gone wrong. And there's some song and dance that happens when that obstacle is pointed out. So if you look at this wavy snake, it's just the activity. And the y-axis doesn't have really any meaning. It just is the activity sort of changing over time. And if you look at these windows that are slicing through, the windows mark a point where you can call attention to an obstacle. And it's a sliding window. So if you'd like, you could say, I sense that I'm going to get stuck. I sense this obstacle is coming, and you could call it out ahead of time. Or you could call it out right after the obstacle has happened, or way after the obstacle has happened. And the tutor can do it, or the student can do it. So there's a division of labor. Who's going to be the one to recognize this obstacle? So let me show you a little bit about what this looks like. So let's just look at who marks the obstacle. Tutor and student working together. The student has forgotten to take the reciprocal. That fraction's a little bit hard to see. She's forgotten to flip the fraction, if you remember back from doing these procedural division of fractions problems. And the tutor says, hold on. And the student stops, lifts up her pencil, and looks at the tutor. Right? Something's going on. The tutor's found the obstacle. In another case, a student writes down the problem, and as soon as he writes it down, he looks at the tutor and says, can you help me? Anticipating that he's going to get stuck, so he's catching it ahead of time. Whereas in this case, the tutor's caught the mistake just after it's manifested. And here the tutor's calling it out, and here the student is calling it out, and here the tutor's calling it out. So when is the obstacle found? Immediately after. We just looked at this. The hold on, as soon as has made the first mistake. This one is way delayed. So the student has finished his homework. Well, I say way delayed, 3 minutes, right? So he's finished his homework, and he's gone on to other things. The tutor comes over and says, can I check your assignment, right? Really different temporal structure leading up to the moment where you're going to talk about this failure. There's also really different approaches to describing the obstacle. Here, the tutor spells out a very specific obstacle. So, the student spells out an obstacle. The student says, can you help me? The tutor says, yeah. And the student says, 1/3 minus 4/9. Just says what the obstacle is right away. This is what I'm stuck on. In this case, the tutor plays it a little coy. And after 24 seconds of reading his homework, the tutor says, do you want to look them over with me? Which is not, for the student, that means there's something wrong, right? Otherwise, he would have just been given the paper back. So they steel themselves to look at the assignment. And here, notice you have no idea what the obstacle is, right? There is an obstacle, but there's no description of what it is. And here, they're precise about the description. Okay, so after the obstacle is found, there's then a period of storytelling about why that obstacle came to be. And it starts getting a little juicier at this point. It gets quite interesting. There are always a number of events that precede the obstacle. And again, this is a sliding window. You could try to tell your story of why you think someone's going to fail. I think this set of events is going to happen that causes you to fail before it even happens, if you feel strongly about your guess. Or you can wait till it happens and reflect back on it. And there's often competing theories that happen in this causal window. So you might get the white circle led to the gray circle, which led to the failure point, or the black circle led to the failure point, which are competing theories of what led to that failure. And what's quite interesting is this window can move, and most importantly, it can be expanded. You could look for causal theories very quickly and move on, or you could open it and really sort of treat it as a moment that deserves reflection. So let's look at some of these stories. Ooh, yeah, that's really much too small. So I'll read the transcript to you. 5 plus 4 is 8, is what the student says, which is wrong. 5 plus 4 is 9. And immediately, tutor corrects her, says 9. And she says, oh yeah, I get confused, that's why. Which is a tiny little story wedged in there. Oh yeah, I get confused, that's why. Pretty interesting attribution of why you've added these. In this case, same episode, similar problem later on. The tutor says, you need to slow down though, which is a different causal theory. Is it speed that's causing the error, or is it confusion that's causing the error? And keep in mind that you would do very different things if it was speed than you would if it was confusion. If it's confusion, you have to intervene to deal with whatever's confusing about it. If it's speed, then you have to deal with some intervention to slow down. In this case, you get something very specific. The student is distracted and laughing, and he says, but my friend over there has a mango, and he's pointing to his friend with a mango. And I don't know what happened with the mango, the camera's not pointing there, but something with the mango is causing his distraction. Like nowhere in attribution theory are mangoes described as possible causes, right? Which is sort of a nudge to look at the stories that people actually tell in their real sort of obstacle moments, right? Sometimes these appear as chains. This episode has multiple causal attributions. The student has struggled on a problem. He says, I suck at this. And the tutor immediately shoots down that theory. He says, no, you don't. And he says, I'm just trying to figure this out too. So is it that the student's bad at it, or is it that they're in the midst of a learning process and things are hard in the midst of a learning process? And then the student comes back and says, you're making it confused. And the tutor says, what? And the student says, again, you're making me confused. So 3 attributions: making me confused, I'm bad at this, I don't have the skill to do this, or we're in the middle of a learning process. But this phrase, you're making me confused, is a little chain. The tutor is doing something to make me confused, which is making me unable to make progress on this problem. So you have a little chain in there. And similarly here, student says, I don't get it, and the tutor now guesses, oh, is it because it's a negative? Is it because it's a negative sign? Is that what was confusing? So now instead of the tutor causing confusion, a representation on the page, a negative sign causes confusion, a little tiny chain. And then you have temporal structure, when these causes are posited. In this case, where with I suck at this, no you don't, I'm trying to figure this out too, you're making it confused. All of this happens before they've resolved the problem. The obstacle has manifested, but there's no solution to it yet. They're in the midst of it, right? And generating these theories about what caused the problem. In contrast here, 5 plus 4 is 8, it's corrected immediately, 9, and then you get the attribution, oh yeah, I'm confused, that's why. And they're really different information opportunities here, right? Student not only has a sense of what went wrong, but they know the solution, and then they're telling a story about that, versus here, they only know that a problem has arisen, but they haven't resolved it, and they're working with that information to tell the story. So, back to computer science. What does this mean? This division of labor, temporal structure, and content of these stories. For our norms, it opens up a number of opportunities for us. The first is quite simply giving students agency. For thinking of the division of labor of these stories, have the students tell the story about the obstacle, what it means, have the student tell the story about the causes, give students agency. Debug code immediately. Debugging code immediately keeps present the information that you have that caused it. Right? Whatever sort of model that you used to design your code, whatever things went wrong, it's more likely that you're going to retrieve those. However, there's also a chance that it gets overwhelming and that taking a break and coming back gives you perspective, so we wouldn't want to rule it out. Extending the causal search window, asking the tutors to spend more time and the students to spend more time on this, accept that it's difficult. There's an amazing number of causes, and that we need to look very carefully, look very strategically. Consider chains of causes. In other words, don't think of them necessarily as competing theories, but think of them as informing each other. Maybe it's a little bit of speed and a little bit of confusion. And consider causes that come from the teacher and the student. If we think about situated cognition and take it seriously, both of these parties are present in that moment. And the story about what's going wrong could involve things the teacher is doing and things that the students are doing. From a professional development perspective, essentially reflect on all of these possibilities. Do we want to do these? How do we want to do these? What would it even look like in discourse? Let's watch video together of students coding. Really accepting the teachers as knowledgeable and giving them a shot to reflect on these questions on their own and sort of iteratively revise our approach as an education community. Okay, so that was the first conjecture, focusing on failure stories. The second is looking at body movement, perception, memory, testimony, introspection, and reasoning coming together to create routes toward knowledge. I'm going to first just focus on body movement and then come back to the others. So there's a pretty sort of interesting thing that we can do with our bodies, which is that we can, in some sense, leave our canonical selves behind and become something else in our body movements. We do it routinely in gesture. For instance, if I talk about, I don't know, the Cubs hit a grand slam against the Dodgers a couple nights ago, and if I do, I don't know if he's left-handed, someone's from Chicago. I think he's left-handed. Like if I do the swing right, I've left my body behind and I've thrown it into his body. Educational researchers have documented this phenomenon for decades in some sense. Students becoming viruses, asteroids, points on a graph, squirrels collecting nuts, even mealworms in science and mathematics contexts. And it goes by a number of names, empathic embodiments. There's a Japanese word, kobitos, which means little imaginary people that you imagine in the space. Character viewpoint from the gesture literature. Agent perspectives from complex systems. Participatory simulations and participatory models from similar literature, and liminal blends. To sort of give you a more authentic example of this, there was an ethnography of a population of natives living in the Amazon, called the Runa. They live in Avila. And Cohen in this book documents their practices. So he says, people in Avila try to make sense of these various selves that inhabit the forest by trying to see how they see and by imagining how different perspectives interact. One man took delight in explaining to me how the giant anteater adopts the perspective of ants in order to fool them. When the anteater sticks its tongue into any nests, the ants see it as a branch and unsuspectingly climb on. In their interaction with animals, the Runa in many ways try to emulate the anteater. They attempt to capture the perspective of another organism as part of a larger whole. People in Avila take great pleasure in finding a viewpoint that encompasses multiple perspectives. So it's almost like a survival instinct to outcompete the animals in the forest by imagining what they're thinking, by immersing into their perspectives and understanding a scene from multiple viewpoints. So you can do this in a, okay. Oh, hold on, let me come back to that. You can do this in a much less culturally authentic way with undergraduate students. I asked them to learn packet switching, which is how data is routed around the internet. And I read, so this was with 10 undergraduates. There were 24 sentences describing packet switching and then a post-test afterwards. And what I did is really non-traditional communication protocol where I would read a description of packet switching and ask the students to gesture what they were thinking is happening. It was a way of externalizing their thought process, seeing them build the model as they were first coming into contact with these ideas. So it looks like this. Okay. When a computer sends an email to another computer, it chops up the email into a few words and groups the words in packets. So it looks like that. So let's look at one sentence. As the packets travel on the pathways, they enter large machines called routers. And let's watch how she does it. Now I'm going to turn on the one below. So there they are, entering the router. I'm just going to turn on all of these, and you can just see the common embodied language here, which is sort of constructing the object and the packets entering it, or the packets entering into an object. Sometimes it's done with a trace, sometimes it's just bracketed, other times the whole thing is molded very carefully. And what you can see in this simple gesture is sort of the hands becoming two different things. The hands being the packet in a moment, and then the hands leaving the packet and becoming a router that the packet's entering into. Mm-hmm.
Are these students exploring these ideas for the first time, or like
Yes.
the early stages? Okay.
Yeah, so
So
that was
learning.
one of the prerequisites that they hadn't learned this concept before. So if we look carefully at what the students did, this study was looking at two things: the point of view that they took in their gestures and how they organized space. So in this sentence, packets travel to the nearest router in the network. You see them start here, and they end up over. They do a big start. Sorry, they start here, and they loop all the way over and end up on the right side. But then what happens is that the packets leave in the next sentence. The packet takes the left pathway and the right pathway. They leave from the center, and they come out. So if you look at this depiction here of space, it actually doesn't make any sense. The packet has traversed over here, and then a moment later, it's departed from here. It's jumped in space, and it ended over here, and then its very next move, it departed from here. If you watch someone who does this in a spatially consistent way, you see the packet come across, and it stops at the center, and then notice that right and left are understood relative to the packet. Packet's moving across this way, and it can take the right pathway or the left pathway. So it's keeping space organized, right? Even as you move across viewpoints, as you become the packet, as you become the computer, as you become the router, you're still anchoring these elements in a coherent geographical space across sentences. And this was the factor that predicted learning. I know it's always hard for me to digest these graphs very quickly in a talk, but essentially what it says is that between the low learners and the high learners, they were both adopting multiple viewpoints. They were both becoming routers, becoming packets, becoming computers in their gestures. That didn't predict learning. What predicted learning, and really dramatically, was this spatial congruence across sentences. The high learners were incredibly congruent in their gestures, building a really nice geographical model, and very few incongruent gestures relative to the low learners. So one way to think about this is in a study that we did afterwards with little kids. And in this study, these little kids are doing something very similar to what the college students did, except instead of becoming packets and computers, they are shrinking down to become particles, to understand about solid, liquid, and gas phase change. And this is what a kid looks like when he's becoming a particle. They're really excited. They were incredibly excited, unlike undergraduates. By the time we grow up, we sort of lose this spirit, right? But kids are experts at it. They truly are experts at it. And what's interesting about this study, if you now watch the top right screen, is as they become a particle, they're not just on their own in their imagination. You can see a little particle that's following him around. They're being tracked by Xbox Kinect sensors.
Oh, they like it.
And oh yeah, they absolutely love it. So and to tie it back to the previous concept, this frees you up to be a particle, but it gives you space. You don't have to use your sort of memory to track where did that packet end up, where did it go here, did it go there. You're seeing the representation on the screen as you are immersing in this role. You're also both a packet and you're seeing the overview, this like overview perspective at the same time, which is also pretty amazing. That's impossible to do in your own gestures. So I'm going to show you a clip from this for the purpose of illustrating that what happens is that students end up becoming particles and they end up becoming scientists, and they move back and forth between these two roles. And it's amazing to see. As scientists, they're forming observations, they're conducting experiments, and as particles, they're playing as particles. And they're standing in this model and they're giving life to it. So what we're going to see is this student proposed to create a caterpillar in the class. This is a little bit quieter. but I have the salient moments transcribed, so you'll be able to follow along.
An idea she wants to test. If we can make a caterpillar, and we can see if it's one particle or.
This is what the students see.
Okay, everyone, that's my idea. Squeeze on. Squeeze.
So you get this really, really nice dovetailing between the two roles. Molly has an idea she wants to test. See if we can make it a caterpillar and see if it becomes one particle. Just perfect, so perfectly spelled out experiment for a first grader. Everyone get the idea now, and now they're testing it. Now they're in particle mode. And what's so cool about this is if you zoom in, like the student who is a particle, whose body is creating the experiment, his body is leaning out to the teacher in this sort of scientist position and saying, look, it's red. When you're close to each other, it's yellow, and when you're far apart, it's red. And the teacher is allowing play to play a role here. Sorry, no pun intended. Allowing play to sort of fit in, right? When the student peels away here, she says, no, go back. This is great information. Let's do this. And it takes a very playful moment as a particle and meshes it really nicely with the scientist role. So going back to coding, the godfather of computer science education, Seymour Papert, wrote a book called Mindstorms. And he shares his programming language that he designed for kids called Logo. And in Logo, you can do very simple things like move this triangle, which he calls a turtle, up to the right, down to the left. So you would go forward 100, turn right 90, forward 100, turn right 90, forward 100, turn right 90. And if you do that 4 times, you get a square. In this book, 30 years ago, this is a paragraph that I read recently. A student has tried to do a square and a triangle and made a mistake, and this is what Papert says. In many ways, this bug can be fixed. Pamela found one of them by playing turtle. Turtle is the triangle. By walking along the turtle's track, she saw that the triangle got inside the square because its first turning move in starting the triangle was a right turn. So she could fix the bug by making a left-turning triangle program. So in the moment that your code breaks, using your body to step in, to model it, and see that precise moment in code where something's gone wrong, our collaborators have started to design this tool called Pixelbot, where you have a turtle, and it can move around a grid, and it paints. It can paint lots of colors. It's a sort of blend between art and computer science. Here, if you can guess, the turtle's making drawing a picture of himself, self-portrait. And what we're hoping is that, so these are some of the spaces where we've been working with students, and we can provide a grid that you can walk on top of, or you can step in and become the turtle, formalize this sort of mini idea that Papert observed, and really take a moment where your code is broken and debug it with the body, right? And from the perspective of the STEP project, I should say that the project of the kids playing as particles is a part of a big project run by Noel Ennedy and Joshua Danish called Science Through Technology Enhanced Play. So there are lots of really fun work coming out of that. If you take the insight from there, students can both be the turtle and they can be a coder and move back and forth between these two viewpoints and have it be a real debugging opportunity. So in the design of our interventions, we can use the body to debug, we can have multiple viewpoints. And when we set these as norms, it means, could we have a culture where your code breaks and you just stand up and walk to the grid and think like, I just need to slow this down and see what it looks like with my own body? Like that would be a norm, if the norm was to think with your body. And it's not, we don't know what work will be needed to get to that point. And to say, all right, I'm going to be the turtle for a second and just immerse in that perspective. What are the instructions that I'm getting? And then pop out and say, all right, as a coder, what do I want the turtle to do? And what new coding resources might I use? We can design curriculum and software for this purpose. We've already started with that. And in professional development, really reflect on what the body does, affords as a semiotic resource. Okay, so it's 5 right now, and I wonder what we should do.
Time, right?
We have a half hour.
Okay. So I suppose, okay, so I'll do this next part quickly, maybe in 10 minutes, and then that'll hopefully give us some time to discuss. Okay, so we've looked at body movement. Now let's look at these other 5 sources of knowledge: perception, memory, testimony, introspection, and reasoning. In the personal epistemology literature, the idea of a source of knowledge has been constrained to a dichotomy between knowledge coming from inside of you and knowledge coming from outside of you. So a common question that you'll ask a student is, a source focuses on whether people acquire knowledge from outside the self or is by actively constructing it within the self. Does knowledge originate from an external source or from personal experience? And a student would be expected to tell you, you'd ask that question, the student would say, yeah, in this case I see knowledge coming from within me, or I see knowledge coming from authority. In this personal epistemology literature, there was a paper written in 2011 that synthesized the perspective from philosophy on sources of knowledge. And philosophers had long ago abandoned that dichotomy and saw these 5 sources of knowledge. Knowledge coming from perception, knowledge coming from, in other words, coming through the senses, monitoring your own thinking with introspection, reasoning, whether it's deductive reasoning, using rules, blending, imagination. Knowledge comes from memory, drawing on recollections of the past, and from other people. And what's pretty cool is if you watch people as they're making claims about their worlds. This is a science project with a geologist. I worked on this project with Chuck Goodwin at UCLA. And what you can see here is a student who's making a claim about a feature in rock. So what he says, so Dave, the instructor, says, so what are you guys seeing? And the student says, we found one of those Boudinage structures right here. Pinched, there you go, pinched at Dave says, there you go. Instructor says, there you go. Student says, pinched off at the top. And the instructor again says, yeah. So if you look at this over and over and over again, as I did, and you're thinking about these sources of knowledge, you end up with something like this. So perception. The very first move of the instructor is, so what are you guys seeing? And you can see the student angling his head at the rock. It's sort of obvious to say, there's the only way you're going to know there's a Boudinage structure in this rock, which is a sausage-shaped fold, is if you look, right? And he's looking. But there's also a hint that this is coming from memory, because it's one of those Boudinage structures. Oh, it's just one of those, right? We've seen it before. It's coming from the past, right? And it's recalled in that moment. It's not written on the rock. And there's also a really elegant sort of reasoning that the student does at the same time. He's pinching, he's showing you the pinch at the top, and he's dragging his hand down the whole surface of the rock to show you exactly where it is, and describing it in words. So he's giving you the rationale for seeing it at the same time that he's perceiving it, and at the same time that he's drawing on this thing from memory, this idea of a Boudinage structure. And then you get 2 moments. This arrow should also come here, right? The instructor says, there you go, yeah. You're getting testimony in that exact moment from an expert geologist who's verifying it. So you're getting 4 of these sources of knowledge all at once. And I want to show you one more example of this. We saw this example of this early moment where the tutor says, hold on. So thinking about that moment through this sources of knowledge lens, the student is likely going to barrel right through that problem. It doesn't even matter if she would have caught herself anyway. What starts this trajectory towards knowing the answer to this problem is a little bit of testimony from the expert. Hold on a sec. Right? This sort of opens up this new road. And you get a very similar first move here. Look at it again. It's very similar to the geologist. What are you guys seeing? It really prioritizes perception right off the bat. And the student follows and looks, re-examines her work, and says, you can do it. She's not sold that there's a mistake. In part because she's focusing on reducing the numerator and the denominator in the fraction. She's passed over the step where she was supposed to take the reciprocal. It's not really on her radar. And she was circling this as the tutor said, hold on. So it kind of gives the appearance that that's the problem, but it's really the step that should have happened before it that's the problem. So she examines perception, doesn't get anywhere. Then you get a call to reason. The tutor says, follow your steps again. In other words, follow the rules. How do you know how to solve this? The student knows how to do it. She's done this problem multiple times. She says it's right, and she defends her reasoning. 3 goes into 3 once, and 3 goes into 3311. Right, so she's thinking about reducing the fraction. She's not thinking about the reciprocal. You also get a really interesting introspective moment. A few steps later, the tutor says, "So what happened here?" and points at that fraction, the 11/3, and she shrugs. I don't know. A moment after she shrugs, she says, you have to do the reciprocal, and she points at the 11/3. And what's so interesting about this moment is her point touches the 11 and the 3. So it's similarly to the geologist, she's arguing that these two numbers are relevant, right? We know that she knows the reciprocal, she's done it, but even in her gesture, she's arguing, like, look, she's reasoning about what the reciprocal needs to do, it needs to change. She's of course looking directly at it, and this comes from memory. It can't come from anywhere else. The word reciprocal isn't written anywhere. And in a really cool move, as soon as she says that, you can see the tutor's body lean back out of the space. He's done, his work is done. He leans back and you can't really see, but he smiles. It's laminating the expert's testimony on top of this moment, like immediately. So you have reasoning, you have perception, you have memory, and testimony that comes a half beat later. And then student, this dramatic, oh yeah, right, of course I know that. But the oh yeah doesn't come until after the tutor signals it, that it's the end of the exchange. So by the time you get to a right answer here, you can think to yourself, like, what's the source of knowledge? How does she know the answer to this problem? And like, the tutor's early testimony, hold on, is in there. Her looking at the problem, inspecting it is in there. Drawing this idea from memory of a reciprocal, thinking about it, reasoning about it. The tutor's testimony right after the fact. These sources of knowledge are all wound together in this moment. Big sort of slide here. What this series of steps describes is, back to the computer science world, is a debugging process. This is a sort of distilled version of all the things that you can do when your code breaks. In short, the steps are the bug is causing an observable problem, find the bug, fix the bug, learn from the bug. And there are a whole bunch of steps you do in between. If you look at this list with those sources of knowledge in mind, you can just see some popping out at you. So this was created independently of that list. The first step is really just perception. Describe what's going wrong. Run your code and just see what is happening. Don't worry about memory, don't worry about reasoning. Just tell me what's happening. Describe the unexpected effect. And if any steps led to it that the user did, did the user type anything in, did the user click play, it's just observe. And then you get into this world of finding the bug and fixing the bug. And what I like about the sources of knowledge framework is that it can really structure some things you do here. So do I go to door and get a little bit of testimony? Do I reason through, or do I call to memory all of the things I know about code? What have I learned in this course? I just take a moment to bring that up to the surface. can I reason through step by step what this code is doing, walk through, to try to explain what's happening. So these sources of knowledge, though philosophers have been using them, they can actually become guides to these two steps in here. Estimate the origin of the unexpected effect. That's the hardest, this is one of the hardest steps. You don't know, you've written the code, something's going wrong, where do you think it's going wrong? Each of those resources could sort of be something for you to latch onto to anchor your search. And you could do that with each of these debugging steps. And I'm going to stop there. The last step, metacognitive reflection, there's just no time for it, but just to give just to sort of clue you into it, the idea is that we don't want to prescribe how the stories are told. We don't want to prescribe how the body is used and which of these resources are used. We want the community to make those decisions themselves. So the idea is to work with the tutors and to work with the folks who run a 9 Dots, who are really interested in work. We can share some of these ideas and we can listen to them, and in these teacher education workshops, and by analyzing video of students debugging over the next few years, what we'll do is gradually formalize a language around these concepts, around the structure of failure stories, around all of these resources, see how they're being used, and ideally the educators themselves and the students themselves can have a voice in what sequence they want to do them and how they want to revise the division of labor in their failure stories, when it's appropriate for the student to take on all of the responsibility. Should you be debugging right away, or is it just too overwhelming? Do I need to take a break? Those are just gonna sort of emerge through the community, and we see our job as researchers sort of describing these factors that are present, no matter, they're gonna be present in failure stories, gonna be present in these epistemic resources, draw the teachers and the students' attention to them, and hopefully work with them to metacognitively reflect on it on their own, and help us design these interventions together. So that's it. Many thanks, and I'll just sort of emphasize again that we are really looking for collaborators. It'd be wonderful. I'm so excited to learn from everybody here. I've only really been here a week, and I'm excited to sort of give you a very taste of this project. I'm sorry we don't have results, anything more concrete, but this allowed me to tell you a little bit about my work, but also introduce this project. So thanks very much. Really appreciate it. I think we have a little bit of time for questions.
Question.
I can't remember the term you used for it, but I was really interested in that part where you're talking about the people making the motions about the packets, and that
Yeah.
the ones that were like,
Spatially congruent.
That's the word
Yeah.
I wanted.
Mhm.
The ones that were spatially congruent, like were higher performers. Like, do you have any idea why that connection exists?
I mean, I think there would be a number of explanations. We don't have sort of experimental evidence. The most obvious, so actually there is a little bit of evidence. So there is research that shows that texts and stories that are told from multiple viewpoints, if you hop around in your story, it's less likely that it'll be understood. It's more cognitively taxing. So this is usually done in like rather mundane settings, like I'm going to tell you where the clock is located and where the stairs are located in the window, and I'm going to sort of change perspectives as I do, and it's confusing, right? So in some sense, you're just familiarizing yourself with this world of packets and routers, and sometimes packets are going this way, other times they're going this way, other times they're going this way. It's just an extra cost to think of those as independent simulations and then stitch them together later. If the body's always used to moving through space in a coherent way, then gesturally, if it's presented in a spatially coherent way, even if it's difficult to sort of remember where it came from, it has payoff. I don't know if that's a satisfying answer, but it's a possibility.
One way to think about it is to reason through how a person is learning and thinking in terms not of some kind of soliloquy or like solo production, but as emerging from the whole situation where it's that person was standing and speaking to David, I presume. And to what extent do I draw, like I'm speaking to what extent do I draw on this moment of you interacting with me in order to learn and grow myself as a thinker? So am I just like, well, there's this thing there and actually does that, or am I looking for cues from you in real time to keep maintaining a common ground and looking to how you are attending to my thing? So my performance, in a sense, is reacting to your responses to the performance. So I'm making sure that it's coherent for you, and in that sense, and in that way, creating opportunity for me to organize my own thinking. So that's how the discourse helps me grow as a thinker.
The flip side of this is that if you analyze film, there are viewpoint switches happening constantly. So if you have a little bit of time after this, come up and I'll show you the opening sequence to Finding Nemo. And in 10 seconds, there are so many viewpoints. It's remarkable that we don't get lost. So I think it's still somewhat underexplored, and we don't understand it fully. Experts clearly can hop around viewpoints and mix up space. It's not urgent for them. But that's sort of a problem for students, is students need it to be organized very, spatially.
I just wanted to ask a little bit about that interaction and how you analyze the times when the students were actually asking for help. Did you find in all these conversations that you analyzed that there was a big variability? Were there certain students who always asked for help really quickly, or?
Is this in the packet switching study?
Yeah.
So this is in, I guess now I could probably say like a former life when I was still doing like a controlled psychological experiments. So they weren't allowed to ask questions.
Oh, okay.
That would have been
you did control that, yeah.
yeah, it would have been violated the
So they
controls.
couldn't ask for help?
They didn't. They couldn't have. We just spoke very deliberately, gave 5 seconds in between each sentence, and then and we did it in 2 rounds. They had a second round to do it, but there were no difference across the rounds.
And so, but then the other one you showed us with the kids in the tutoring center,
Yeah.
they could ask.
Oh, absolutely. Yeah, that's a naturalistic.
So,
Yeah.
So you didn't try setting it up.
In that case, that's not set up in any way. That was like spending 4 months at the Learning Center and letting the students and the tutors film themselves, and me at other tables tutoring them.
Oh,
Yeah.
And then identifying I guess establishing attributes of the failure. Has there been work done to try to link that to the source of knowledge?
This is the beauty, what I see between them. As far as I understand, it hasn't been done, right? So you think about psychologists, and they would stop at ability and effort. Those are essentially the two. They consider luck and they consider a task structure. But as you're sort of pointing out, right, you could attribute failure to something quite specific, to one of the specific sources of knowledge. You could get even more narrow. You could attribute it to a sequence of sources of knowledge. Maybe I'm always going to testimony before I look myself. Maybe I'm forgetting that I actually know a lot about computer science and I can bring that to memory. So yeah, that's like the spirit of the project, to take these attributions of failure and make them more specific and thus more actionable. Right? You want attributions that are controllable so that you can actually do something about it. And I think that is underexplored, bringing those two together, and that's something that we're really excited to pursue. Yeah, that's an awesome, great question. Yeah, Michelle.
So I'm thinking about a lot of people in this class or in this session right now are in a class where there's an ongoing conversation about the readout narrative as a very big distal narrative, and I'm wondering. Wow. I like the idea of thinking of debugging and sort of proximal failure and narrative around that, but I'm wondering if you ever see interactions between personal, single failure narratives and maybe these larger narratives that are social.
I am just so under-equipped to answer that. I don't know. I don't have any. I haven't looked at a bird's eye view yet. I'm at like a line by line level. It's even a word by word, pause by pause. Focus. So I would speculate, but the only sort of little bit of evidence that I can tell you is that I also interviewed the students at the end of each session, and you can see these moments getting reified in their identities. It's not any more their identity when they're interviewing with me than they are here, but they are reflecting on something in the past that's gone, it's over, and you can see these, like the very same moments that came up, you can see them getting anchored. So if someone had the courage and the resources to see how they get reified, that would be wonderful. What I really am frustrated with, and I'm really frustrated by the construct, how grit is being used in schools. I think a lot of folks are. There's nothing wrong with the psychological work. There's nothing wrong with the construct. Being gritty is wonderful, but if it becomes a knee-jerk story, like the sort of weeding out story or the grit story, then what you're doing is you're just telling the student over and over again to work harder, and the story becomes just you're not gritty enough, rather than there's a number of complex factors that are causing any moment, and the school needs to slow down that moment, accept that they're responsible also as the teachers, and that the students are contributing in some way in the community, however far you want to go, however much you care to solve the problem, and really make that story much more complex and adapt, rather than just have the knee-jerk story. But I wish I could see how these cascade into people's lives and how the effects are pretty
And
much.
just if they pop up in the moment, like was sort of my
Oh.
question. Yeah.
Oh, like do they appear just in random moments throughout the?
Yeah.
That's something we should really look out for. That might be a nice measure of whether a new debugging mindset is picking up steam in the community if these stories are appearing in different contexts. Yeah, that's a really nice idea.
I don't know if you mind talking a little bit more about the context of the project. What's the state, what things have been done, what things you're looking to do, and especially like I'm very interested in what you're doing, so I would like to know what are you looking for in your collaborators?
Yeah. Oh, in future collab. Oh, I mean any.
Yeah, for this project.
Oh, God, I mean, and I think for anybody who's interested, I'd love to just talk with you and see if there's any overlap. That would be amazing. But to just give you a little more background on the project, the Learning Center is we're really positioning them as central to the project. So they're actually the PIs on the grant, which was not easy to do with the National Science Foundation, but they are getting a lot of the funding. So they're really invested in the project, which is amazing off the bat, and all of the research team is invested off the bat. And what we've done so far is mostly talk, right? So we only found out that we got it 3 weeks ago, so we've had a few meetings where we're bringing these ideas up to the surface. What we have done throughout the summer is start building the Pixelbot software, which we really like because of the connection to body cognition and the body as a possible debugging resource. And what I've been working on is how to code debugging stories. So that's what the math project is about. Can you reliably determine who found the obstacle? Was it the student or was it the tutor? Can you see what they're blaming for that event? And we have to be able to code those debugging stories really well so that we can see if they change over time. Our main measure will be interaction analyses of the exchanges that happened around struggle, around bugs in the code. So we'll find all those moments, and over 3 weeks of a summer workshop, we'll code them and see if over time, are students taking more agency? Is the causal search window expanding? Are they considering more factors? Are they justifying their reasoning for their debugging approaches? So we'll have to sample randomly throughout the 3 weeks of the workshop, and then we'll code them in the spirit of interaction analysis, but hopefully be able to pick up on changes in debugging interactions over time.
There's a considerable aspect of the project we just haven't had a chance to speak about today, but certainly a lot of the grant is going towards, and that's the professional development of the
Undergraduate tutors, yeah.
Do you want to say a word about that, maybe?
Yeah. this is a reality. So informal learning spaces are wonderful because you can really do something new, right? We don't have anybody telling us how to do this project. It's our own will is in some sense the barrier, right? How far do we want to go? But the contrast to that is that you're not working with seasoned teachers, right? So the staff at 9 Dots, they're excellent teachers. We've been immersed in it. But you need to bring in support, right? And you can't pay credentialed teachers. So the students who come in are undergraduate computer science educators. And this last summer, it was amazing working with them. They're so interested in picking up new ideas about pedagogy, and they were crafting the curriculum, and we were reflecting on stuff together, only in an informal way. We haven't actually collected any data on this. So they're really, I mean, it's an amazing group of people to work with. Just when you work with undergraduates in general, it's an amazing group of individuals. But it's going to be, anything we want to do is mediated through them. So it's a sort of two-stage intervention. It's what are our professional development sessions going to look like with them? What kinds of conversations do we have? Can they implement? Can they act on it in the moment in their teaching? And then how does that trickle out into the students? So this is, yeah, as Dor says, it's a giant part of this, and we'll have to sort of see what these conversations look like with the tutors. I'm really optimistic that they're going to be really lively and interesting, and that they're going to be up for acting on them. But it'll be difficult. It's hard. It's very hard to teach, as we all know. So yeah, we'll have to have our expectations limited in some way. Yeah.
There are a bunch of groups in the Bay Area that are focused on bringing coding to like K-12 groups.
Everywhere.
Yeah, I volunteered with a couple of them, and it
cool.
seems like there's a lot of focus on like idea generation and design and like application of code. And I'm wondering if you guys are seeing that debugging is something that is currently not focused on at the K-12 level, or if it's something that just hasn't been studied. Like where. You know what I mean?
Yeah.
Are you filling a gap, or are you just studying something that
No,
is
I think
currently
we are filling a gap. I think that would be fair to say. I think the state of computer science education research is still pretty young, like nothing compared to math ed or science ed, right? And when I come across debugging in the literature, it's just given short shrift. It's like, okay, and students are debugging, and that's a great thing about computer science. But I don't think anyone has yet done a deep dive into what the difficulties are around debugging and how to support students to strengthen that practice. But yeah, there's a lot of talk about project-based. It's an amazing skill to invest time in, even if you don't become a coder, right? There's like the economic argument now that we need coders, but then there's the argument that computational thinking is just core to just sort of a way of thinking about the world, so that's beneficial. And then it's also just a set of sort of creative application of ideas, and you can really build your own things, which is incredible in these project-based lessons. But yeah, I think it's underexplored. I hesitate a little bit to say it because you never know what's out there. But I think we're filling a gap. Yeah.
I have a quick, I guess, the last question.
Sure.
About the kids when they come in, do we know if there's been any research about around what you're calling narratives of failure in terms of the systemic differences between populations along any dimension at all, culturally, socioeconomically, anything at all?
I don't know. I'm not sure. I know I can sort of voice the. No, I don't think I know. I think I'm not sure. It would be you'd have to do quite a project to know, right? You'd have to spend a lot of time with a lot of families. One of the studies that I didn't cite is a study by Eleanor Oakes looking at storytelling around the family dinner table, and it's a fantastic study. You see multiple family members reconstructing the event, positioning who's to blame for it, positioning what caused it, who's going to take the fall for it, right? What it felt like to be a part of, like, in this case, I'm thinking of the story of the mom accidentally feeding her child like a spicy green pepper instead of a green bean, and the kid's mouth is on fire, and they're retelling the story. So I would say definitively, I mean, it might vary by family, it might vary by socioeconomic status. I don't know, but it would be to really answer that question, to have a sense of what the storytelling practices are at home. I think it'd be wonderful to know, because you could then build on them in the school and not sort of really change the discourse context. And maybe that's something we could think about doing, spending time with the families of these students and really seeing what their storytelling practices are like. That'd be a huge opportunity, but big investment. So thanks everybody so much. Just really thanks for listening and letting me share this work. Really appreciate it.